Group 18 elements: helium, neon, argon, krypton, xenon, and radon. All these gases are chemically unreactive and they are known as noble gases. Their atmosphere abundance in dry air is up to 1% by volume. Argon is the major constituent. Helium and sometimes neon are found in the radioactive origin. For example, pitchblende, monazite, and cleveite. The main commercial source of helium is natural gas. Xenon and radon are the rarest elements of the group. And radium, when decomposes, radon and helium are formed. Both are noble gases. Interesting. These are all points. And you see just electron gain enthalpies. Here neon electron gain enthalpy maximum positive. Okay, na? And helium 48 minimum positive. And here NCRT, here is a mistake in NCRT. This must be here, this must be here, this must be here. And I am saying since many years it is not changed. Okay. Neon, argon is maximum available. That's why it is 0.934. Okay. Don't confuse with this data. Electronic configuration NS2NP6, helium configuration 1s2. Ionization enthalpy decreases down the group. Of course, they have very high ionization enthalpies. Atomic radius normal, electron gain enthalpy, large positive values of electron gain enthalpy, just now we have watched. And then these are monoatomic, colorless, odorless, and tasteless gases. And they have just weak dispersion forces, or you can say van der Waals forces. Helium has the lowest boiling point of any known substance. It has an unusual property of diffusing through most commonly used laboratory materials such as rubber, glass, and plastics. Very, very interesting. Unusual property of diffusing through most commonly used laboratory materials. This can be a statement in your next examination. Their inertness is because of noble gases configuration, that is noble configuration, completely filled NS2NP6 configuration, and high ionization enthalpy and more positive electron gain enthalpy. First compound prepared by Mr. Neil Bartlett. The reason is very simple. He prepared a red compound which is formulated as O2 plus PTF6 minus. He then realized that the first ionization enthalpy of molecular oxygen is same, almost like of xenon, 1175, 1170. He made efforts to prepare something and finally prepared a red colored compound Xe plus PTF6 minus by mixing PTF6 and xenon. This can be a question. And so many compounds are there. For krypton, we have only difluoride, KrF2. And for radon, we have noticed RnF2, but it is not separated. It is not isolated. Argon, neon, and helium are yet to known. No compounds are there for them simply. And this is xenon compounds preparation. See, temperatures and ratios. When xenon is excess, you will be getting their XCF2. When 1:5 ratio, XCF4, 1:20 ratio, XCF6. Ratio is important rather than the temperatures. XCF4 when reacts with O2F2, again XCF6 and O2. Preparation of XCF6 you can consider. These are unstable, so they are very strong fluorinating agents. You can see here XCF2 plus H2O, and hydrolysis reaction it is, where you are getting xenon, HF and O2. XCF2 is hydrolyzed to give xenon, HF and O2. The structures are XCF2 is linear, XCF4 is square planar, XCF6 is a distorted octahedral structure, chemical bonding, very simple things. With PFI, it forms cationic part. SBFI also you can see, that means from non-metallic compounds. Okay, now it is forming cationic part. And with metals like MF, for example, KF, NAF, RBF, and CSF, it is forming anionic parts. Okay, now xenon fluorides react with fluoride ion acceptors to form cationic species and fluoride ion donors to form fluoroanions. Okay, now this is anion, this is cation. Xenon oxygen compounds, this reaction is very special. XeF4 plus 12H2O gives rise to Xe and XeO3. These three reactions are xenon fluoride partial and full hydrolysis. It is full hydrolysis. These two are partial hydrolysis. XeO3 is explosive and is pyramidal. XeOF4 is square pyramidal molecular structure. These are all we know. Not only these, you can add few more compounds like XeO4, XeO2F2 and all. Hydrolysis of XeF6 is not a redox reaction. Uses. These uses are also important. Helium is a non-inflammable and light gas, filling balloons for meteorological observations and in gas-cooled nuclear reactors. Liquid helium finds use as cryogenic agent to maintain low temperatures, and it is used to produce sustained powerful superconducting magnets which are essential for NMR and MRI, and also used for diluent for oxygen in modern diving apparatus because of very low solubility in blood. This point we discuss even in solutions lesson. There are two things, Bent's disease and anoxia, solutions lesson. Okay. Neon is used in discharge tubes and fluorescent bulbs. Neon bulbs are used in botanical gardens and in greenhouses. Argon to create inert atmosphere in high temperature metallurgical processes and for welding, for filling electric bulbs. It is also used in the laboratory for handling substances that they are air sensitive. Krypton and xenon for particular special purpose bulbs they are going to be used. Krypton for minus cap lamps, xenon is for some photography flash bulbs. Radon is in the treatment of cancer ointments. Done. So these are few important lines of group 18. This is not very lengthy topic, a simple topic, no much compounds, but hydrolysis, their structures, and few important lines about their general properties. That's it. Thank you.